Now, in continuing with trigonometry, we are going to show that if we have the equation, if I have an equation like 3 sine x plus 4 cosine x equal 2.5, and we are asked to solve this equation. This equation we cannot solve. If we try to draw the graph of 3 sine x plus 4 cosine x, it will require we make a table of values of x, and we get the values of sine and cosine, and we substitute and so on, which is a long procedure. That's why in this type of problems there is a technique to solve the problem. What is it? Is this. We will be asked first that the function 3 sine x plus 4 cosine x can be written as r sine x plus alpha. This can be written like this. This can be expressed like this. Why? Because we can say 3 sine x plus 4 cosine x is equal or identical to r sine x cosine alpha plus r cosine x sine alpha. This is an identity. The terms identical. When you have an identity, we have identical terms. This is sine x and this is sine x. The coefficient of sine x here should equal the coefficient of sine x here. This means that r cosine alpha equals 3. This is cosine x and this is cosine x. Then r sine alpha equal 4. These two simultaneous equations, how are we going to solve them? If we imagine that we have r, this is r, and this is angle alpha, then this is r cosine alpha, and this is r sine alpha. This one, r sine alpha, is 4, and r cosine alpha is 3. Accordingly, from this triangle, we can say that r is the square root of 3 square plus 4 square, which is 5. And we can say that tan alpha equal 4 over 3. The angle alpha will be 53.1 degree. R and alpha can be found from now on without using this triangle, and I show you later how. R straight away, it is this number square plus that number square under the root. And the tan alpha is the term containing sine over the term containing cosine, as if you divide this by this. The r will cancel with the r, so we get tan alpha equal 4 over 3. These two means the following. That means that 3 sine x plus 4 cosine x is identical to 5 sine x plus 53.1 degree. This is a very, very important conclusion. How can two functions will be replaced by one function? Again, I say, these are two functions, 3 sine x plus 4 cosine x. They are replaced by one function only, 5 sine x plus 53.1. The graph which we were saying difficult for us to draw for 3 sine x plus 4 cosine x, now we can draw it. It is a graph of 5 sine x, but moved to the left by an angle of 53.1 degree. That's it. Therefore, it is much easier. Two functions became one function. It is easier to draw the graph. One more thing. If I were asked that this at the top is called f of x, and they were asked what is the maximum value of f of x, then I would say, now I know that the maximum value of f of x is 5. Why? Because sine cannot be greater than 1. Therefore, the maximum value of f of x is 5. When does it happen? When that angle is 90 degrees. When x plus 53.1 degrees equal 90 degrees. Yeah, when x equal 36.9 degree. And if we're asked what is the minimum value, the minimum value of f of x, we say is negative 5, because sine can be negative 1. When this happens, when the sine will be negative 1. When is the sine negative 1? When the angle 270, when x plus 53.1 equal 270 degrees. Yani angle x equal 270 minus 53.1, which means 216.9 degrees. This means now we know exactly what is the maximum value, what is the minimum value. Not just this. Now we can answer the question at the top. What is that question at the top? Is that solve the equation 3 sine x plus 4 cosine x, which we couldn't solve before. Now we can solve, because we can put instead of this 5 sine x plus 53.1 degrees equal 2.5, and now we can solve it easily like an AS question. Sine the angle equal 2.5 over 5, and we got the angle and so on. Yani sine x plus 53.1 degrees equal 2.5 over 5. And then we complete the question. This is show you how is this method of replacing, right, two functions, a function containing sine and cosine, by one function, and this function, it will be given to us in the question. I could ask you the same question we did before, but I rewrite it as this: the function f of x equal, right. Now, the function we had before, it is 3 sine x plus 4 cosine x. We are going to write it 4 cosine x plus 3 sine x, right? And we are going to be asked that express, we are given this question to express 4 cosine x plus 3 sine x in the form r cosine x minus alpha. Then we are going to say 4 cosine x plus 3 sine x is identical to r cosine x minus alpha is identical to r cosine x cosine alpha plus r sine x sine alpha. Then the identical terms. Now, cosine x يبقى r cosine alpha equal 4. Sine x equals sine x يبقى r sine alpha equal 3. Therefore, r straight away is the square root of 4 squared plus 3 squared, 5. And tan alpha equal the term containing sine over cosine, 3 over 4. The angle alpha will be 36.9 degrees. Therefore, 4 cosine x plus 3 sine x is identical to 5 cosine x minus 36.9 degrees. Now, this is identical to the other one, but that one is sine and this one is cosine, no problem. If I was asked what is the maximum value of f of x, I say it is r, which is r is the value of r, is the value of r, i.e. 5. When the cosine is going to have the greatest value. The cosine has the greatest value when the cosine is 1. When the cosine, right, theta is 1. Yani x minus 36.9 degrees equal 1, equal 0. Until cosine is 1 when the angle is 0. Yeah, when x equal 36.9 degrees, which is the same conclusion we had before. The maximum value x 5 when the angle is 36.9 degrees. Whether I'm going to write any function in terms of r sine or r cosine, it will be given in the question. And in the question, it will be given to you which form you are going to use. You just apply what you asked in the question, and then you solve the problem. Again here, what is the minimum value? We say the minimum value is minus r, i.e. minus 5. When Lx, you know that when the cosine is negative 1, the cosine is negative 1 when the angle is 180. When the angle x minus 36.9 equal 180 means x equal 216.9 degrees. Is the same conclusion. This type of problem is a very important type of problem. You will have many questions about this. How to express a function which is, in actual fact, a function containing two trigonometric functions, and we make it one trigonometric function. The expression will be given to us in the question. We can have some clever questions about here, like saying to you this question: g of x equal to 4 cosine x plus 3 sine x plus 7, and I was asked find the maximum and the minimum values of g of x. 4 cosine x plus 3 sine x can have a maximum of 5 and a minimum of negative 5. Therefore, g of x can be 5 plus 7 equal 12, or g of x can be 5 negative 5 plus 7 equal 2. But this is the maximum and this is the minimum. We can have another question like h of x equal 6 over, right, 6 over 4 cosine x, 4 cosine x plus 3 sine x plus 7, and we asked to find the maximum value of h of x. You solve it this way. You say 4 cosine x plus 3 sine x equal 5 cosine x minus 36.9 degrees. It's maximum 5 and minimum minus 5. Therefore, h of x equal 6 over 5 plus 7 equals 6 over 12, or the h of x equal 6 over negative 5 plus 7, which means 6 over 2 equals 3. we substituted the extreme values of 4 cosine x plus 3 sine x. We find that h of x has a maximum value of 3 and minimum value of half. This is the end of this chapter. Our next chapter we are going to talk is a chapter from C4, right? It's called coordinate geometry in C4. This is the next following chapter, right? Now we will consider our next chapter is chapter 2 in C4. The chapters say coordinate geometry in the XY plane. Now, in this chapter, we talk about that we can locate the coordinates of any point in the plane by an x coordinate and a y coordinate. Sometimes the x coordinate and the y coordinate are given to us in parametric form. What you mean by parametric form? Like you will be given what we call parametric equations. Parametric equation in which we are going to be given x and y in terms of another variable. That variable is called parameter. Like in example 1 given here, we are given that x equal 2t and y equal t squared. T is called parameter. You have parameter t. For every value of the parameter, we can get the value of x and y. Therefore, it is not a problem. In order to draw this graph, we need to make a table, and in this table, we need to have 3 values. The value of the parameter t, then we find x, then we find y. And after we calculate the values for each value of t, we plot the graph. We put values of t as he mentioned in the table, say starting from -3, -2, -1, 0, 1, and so on. You can have other values of the parameter right? After you substitute the parameter, you get x and y. Then you do as a plotting. And this problem can be reduced by doing something else, by trying to get what we call the Cartesian equation from the parametric equation. This is called parametric equation because it contains parameter t. We are going to get what we call Cartesian equation. The Cartesian equation means it is containing only x and y. How? From any of the equations given, the simple one, we make t subject. Therefore, we have x equal 2t. يبقى t equal x over 2. Then we substitute instead in y, and y equal t square. Therefore, equal x over 2 square. This means x square over 4. This is a parametric equation. This is a Cartesian equation. Why? Because y is a function of x squared. Therefore, this is a Cartesian equation. We call it now this Cartesian equation, which shows that y is a quadratic, y is a parabola, because it contains x squared. Therefore, it is easier to get out, it is much, easier for us to understand the equation of the curve by converting the parametric equation into a Cartesian equation. Sometimes this requires some knowledge of trigonometry. For example, if I give you, say, this equation, now, let us wait for this problem of using trigonometry and saying something else. Can we, using the parametric equation, can we find points of intersection of the graph with the axes? Can also we find where a curve can meet a line? Yes. Let us have an example. If we have an example equation x equal t minus 1 and y equal 4 minus t squared. Now, this equation we are going to know later from getting the Cartesian equation. It is also a parabola, but it's inverted parabola. Say it is given that the equation is an inverted parabola, Now, it is given to us that the parabola is like this. Can we get knowledge about many things? Can we get the coordinates of points A and B where the curve cut the x-axis? Can we get the coordinate of point C where the curve cut the y-axis? Things like this. Yes. If we are going to get intersection with the x-axis, we put y equals 0. Therefore, we got 4 minus t squared equals 0. And t squared equals 4. Yibqa t equal plus or minus 2. This means the values of x are, x could be 2 minus 1 is 1, or x equal negative 2 negative 1 is negative 3. We can also get the intersection with the y-axis. We can get intersection with the y-axis by putting x equals 0. If we put x equals 0, but t minus 1, but t minus 1, t minus 1 equals 0, and t equal 1. If t equal 1, then the value of y equal 4 minus 1 squared, which is 3. Here, but the point is 0 and 3. We can also be asked, for example, to find, right, to find an intersection of the given curve with the line y equal right x right y equal to 2x let's have y equal half x right plus this point is negative 3, yes, when t equal negative 2, x equal negative 3, x equal negative 3, if the x plus 2y, yeah, y equal x, okay, plus now 2x, half x, yes, half x plus 3 over 2. We have this equation. We have to find the intersection of the given curve with the line y equal half x plus 3 over 2. Or 2x, 2y or 2y equal x plus 3. Right. What we do is we substitute x and y in terms of t. then we get, right, 2y, y equal 4 minus t square equal x, t minus 1 plus 3. يبقى 8 minus 2t square equal t plus 2. Right, 2t square. يبقى 2t square plus t minus 6 equals 0. This equation can be factorized into t minus 3, right, no, x equal, right, negative 3, x equal negative 3 by negative 2, t plus 2, I think, and, right, we don't think have this equation can be factorized into 3 and 2, and 3 here, 3 and 2, but 2 here, 3 there, and 2t here, right, and t plus, I want this plus 4 and negative 3, yes. This is negative, right. Negative 4 plus 3, right. Negative should be positive, and this should be negative. Okay. Then we get 4t minus 3t equals 0. Therefore, get equal t equal 3 over 2, out t equal negative 2. Therefore, x equal t equals 3 over 2, يبقى x equals 3 over 2 minus, right, 1 equal half, or x equal negative 3. Then we got the value of y equal, right, 4 minus t square, y equal 4 minus 9 over 4, okay, 16 minus 9, 7 over 4, and y here equals 0. So we got it 2 points of intersection. It was easier to solve this kind of problem by converting into Cartesian, but we say in parametric form we have no problem, we can solve the problem. In parametric form we can get intersection with axes, we get an intersection with the x-axis, we can get intersection with the y-axis, we can get intersection with any line in the parametric form. But if you would like to change it to Cartesian form and then solve the question, it's the same. So we say it is possible in the parametric form to do everything, but if you were asked to convert it into Cartesian form, then you should find its Cartesian form. Let us find here its Cartesian form. We were given x equal t minus 1, and we're given y equal 4 minus t squared. From here we say t equal x plus 1. We substitute here y equal 4, y equal 4 minus t minus x plus 1 square. Therefore y equal 4 minus x square plus 2x plus 1. This means 4 minus 1, 3. Then the equation is 3. Right, minus 2x minus x square minus 8x minus 4, that 4 minus 2x minus x square. And this is a parabola, and a parabola inverted. We have, and here we found that the way to convert from parametric into Cartesian is to substitute, to say t in terms of x, and then to substitute it in y. But we will want to find that we have a different type of problem. This procedure cannot be done. This is the questions of like this. If we were asked, if you were given the following, if we were given that x equal sine t plus 2 and y equal cosine t minus 3, and we wanted to convert this into Cartesian equation. We wanted to convert it to Cartesian equation. When you have a question like this containing trigonometry, parametric using trigonometry, you ask yourself the following question. Do you know any identity containing the trigonometry in the question? Yes, I know. What is it? I know that sine square t plus cosine square t equal 1. Then substitute. And instead of sine t, you got x minus 2 square. Instead of cosine t, you get y plus 3 square equal 1. This is the Cartesian equation. What does it represent? It is a circle. Center the point to a negative 3 and radius equal 1. Whenever we are given, I say again, whenever we are given the parametric equation in the trigonometric form, there are two ways of solution. The first way of solution that you ask yourself, do I know a trigonometric relation, trigonometric identity between what is mentioned in the question? Then I use it and do it. Another example. If we are given something like, parametric equation like x equal cosine t and y equal 2 cosine 2t. You ask yourself, do you remember any identity containing the trigonometry in the question? Yes. I know that cosine 2t equal 2 cosine square t minus 1. Then we substitute. Cosine 2t is y over 2 equal 2 cosine square t means x squared minus 1. This means y equal 4x squared minus 2. Whenever we are given, I say again, you look at the question and you ask yourself, do you have a trigonometry relating the two terms in the question? Yes. There is a rule containing cosine 2t with cosine t, that cosine 2t equal 2 cosine square t minus 1. Then we can get the Cartesian. If we have this question, x equal sine t and y equal sine 2t. There is no direct rule containing sine 2t and sine t. I know that there is a rule containing sine 2t with sine t, but with cosine t. Okay, we could use it. We could say now that x equal, that y equal sine 2t, which is 2 sine t cosine t. Yibqa y equal 2x cosine t. If there is a way to convert cosine t into sine t, yes. There is a tricky way. You do this. You say 2x and you write here the square root of cosine square t. And you say 2x, the square root of 1 minus sine square t. Then it is 2x, the square root of 1 minus x squared. There is another way can be used in such a problems, which may be easier way. When you don't find a direct relationship, what you do is you are going to take the simpler equation, sine t, and you say sine t equal x, and you draw a triangle. You call this angle t. Sine t is x, but this is x, and this is 1. Sine t equal x over 1. If this side is 1, that side x. But what is this side? The square root of 1 minus x squared. Then you go to the other equation and you find this. You find the following. Y equal sine 2t, which is 2 sine t cosine t. And you use a triangle to substitute. You say 2, what is sine tx? And what is cosine t is the square root of 1 minus x squared. Therefore, there are two ways to find the Cartesian equation from parametric equation when it is given in trigonometry. Either you have a direct identity between the two quantities we have, or in that case you write the identity and substitute, or you take one of them, say sine equal or cosine equal, and you draw a triangle, and then after you draw the triangle, then you substitute what you get from the triangle into the second, I say, equation given the parametric equation, and you will get the Cartesian equation. Another example, right? We got, for example, x equal, again, we got, right, x equal tan t and y equal sine t. There is no direct identity between sine and tan. Then I can draw a triangle. This is angle T. Tan T is x, but this is x, and this is 1. Tan T is x, but this is x, and this is 1. And this is a square root of 1 plus x squared. Therefore, y equals sine t means x over the square root of 1 plus x squared. And this is a Cartesian equation. Now, the remaining part in this chapter, we should do it after we do integration. So we are going to leave the last part of this chapter. After we do integration, we are going to come back into this part of the chapter. Therefore, now this chapter is finished. Now, we go then to one more topic in C3. In C3, then we have left with numerical method. That's all, and then differentiation. Right. Numerical method, in actual fact, some of its problems require that we know differentiation, and therefore we need to start differentiation first. Right? Now, we are going to start differentiation in our next lecture. Differentiation. Now, It is chapter 8. Differentiation. Now, what we learned before in differentiation, we learned only one rule. We learned only that if y equal x power n, then dy by dx equal n x power n minus 1. Earlier in this chapter, in this book, right, we learned about exponential function. We learned about exponential function and logarithmic function, right? And we learned this. If y equal e power x, this very special function called e power x, its differentiation is the same, e power x. And we learned that there's the inverse of the exponential function. There's a function called ln x, but we don't know its differentiation. We don't know what is its dy by dx. Let us find this. If y equal, let us do a proving, right? We say this. If y equal ln x, that means x equal e power y. This means dx by dy equal e power y, and e power y equal x. Even therefore, what is dy by dx, which is 1 over dx by dy, about 1 over x. Therefore, if y equal ln x, then dy by dx is 1 over x. These three basic differentiation, I call them basic differentiation. Y equal xn, y equal e power x, the first algebraic, the polynomial, the second exponential, and the third logarithmic. Now, what will happen if y equal x squared plus 3x to the power 4? And we need to know what is dy by dx. Then we ask ourselves, can we do it? Yes. Maybe somebody would say we expand it as binomial. Now, but we are going to think of something else. We are going to think of, why don't we call function u equal x squared plus 3x? This means y equal u power 4. And therefore we say dy by du equal 4u cube, and du by dx is 2x plus 3. Therefore dy by dx equal dy by du times du by dx. And therefore dy by dx would equal to x squared plus 3x is 4 u cube times this equal 4 x squared plus 3x times 2x plus 3. This can be written in this way. If y equal function of x to the power n, then dy by dx is n f of x to the power n minus 1 times f dash x. And we say that this is done by chain rule. We call it chain rule because we are going to have a chain, u in terms of u, y in terms of u, and u in terms of x. Therefore we have a chain in the middle, u. We got dy by du, and then we times du by dx, we get dy by dx. This we can say rule number 1. The first 3 rules, I call them the basic rules, but this is really rule number 1. Rule number 1 is dy by dx equal, if we have y equal f of x power n, then dy by dx equal n f of x n minus 1 times f dash x. A similar rule will be done if y equal e to the power f of x, then dy by dx would equal e power f of x times f dash x. And a similar rule will be done as y equal ln f of x, then dy by dx would equal f dash x over f of x. These 3 very important rules, they all can, are the result of the chain rule. They all are the result of the chain rule, because in all of them we call u equal f of x. And then we got dy by dx equal dy by du times du by dx. This is how we can prove all these 3 rules. We just need to take examples about this only. Examples about this. If y equal, right, y equal the square root of 5x squared plus 1. Yani means 5x squared plus 1 power half. We say dy by dx equal half 5x squared plus 1 power negative half times 10x. Mean the answer is 5x over the square root of 5x squared plus 1. Right. We can have an equation, another problem like y equal 1 over root 6x minus 3 means 6x minus 3 or negative half. By dy by dx equal negative half is 6x minus 3 or negative 3 over 2 times 6 means negative 3 over 6x minus 3 or 3 over 2. And it is possible, of course, to be asked to find the value of the gradient at a particular point. Now, we can have problems similar to this in right. Can have similar problem to this in E and N. Right. Also. But let us take some more rules in differentiation. Okay. Right. We have a rule number 4 is called the product rule. The product rule. If y equal the product of a function u times a function v, there's a rule saying dy by dx equal du by dx times v plus u times dv by dx, or the other way around, or u times dv by dx plus dv by du by dx times v. It is the same. We call this the product rule. Let us have example. If we are given that y equal, for example, y equal x square, y equal x square, the square root of 3x minus 1. We are going to say u equal x square, du by dx equal 2x, v equal 3x minus 1 power half, the square root of this. Then we have dv by dx equal half 3x minus 1 power negative half times 3. Then we are going to say dy by dx equal x squared times 3 over 2 3x minus 1 power negative half plus 2x times the square root of 3x minus 1. And you can say this is equal 3x squared over 2 the square root of 3x minus 1 plus 2x root 3x minus 1. Or you can simplify it more into 2 root 3x minus 1. And we got here 3x squared plus 4x into 3x minus 1. And we simplify this more into 3x squared plus 12x squared equal 15x squared minus 4x over 2 root 3x minus 1. We have another rule called the quotient rule. Rule number 5. We call it the quotient rule. We can go back to rule number 4. We have number 4. This is rule number 5. What is the quotient rule? If y equal u function of x over v function of x, then dy by dx equal. The rules say this: v of x times u dash x minus u of x times v dash x over vx squared. This is the rule. Let us take example on this. Now, let us have an example: y equal x over 2x plus 5. Then we have u equal x and u dash equal 1, v equal 2x plus 5 and v dash equal 2. Then dy by dx equal to, the rules say v u dash minus u v dash over v square. Therefore is 2x plus 5 times 1 minus x times 2 over v square here 2x plus 5 square. This will be 2x cut 5 over 2x plus 5 square. Now, Another example, if we have y equal x square e power 3x, this is a product rule. So u equal x square and v equal e power 3x, u dash equal 2x and v dash equal 3 e power 3x. يبقى dy by dx equal, right, x square times 3 e power 3x plus 2x e power 3x. We can take e power 3x common factor. We get 3x squared plus 2x. This is the end of our lecture.